solve absolute value inequality. The absolute value of x plus 4 is greater than or equal to 6. Now on these absolute value inequalities, we want to remember that absolute value really is defined as a distance thing. So we're saying we want the distance of x plus 4 to be greater than or equal to 6. Now with distance, that means we can head out this way and say, well, here's a distance of 6. But we also can head out this way and have a distance of 6. And so this gives us a total distance from here to here. We want this whole distance to be greater than or equal to 6. Now to get distances that are greater than, that means we want to get these to be bigger. To get them to be bigger could be, let's say, from here to here. Or we could go from here to here. Do you see how these distances keep getting bigger? Now, because we want those distances to get bigger, if we're starting here, we're talking about all the numbers this way and all the numbers that way. So we're going to rewrite this as a compound inequality. When the shading is like that, it becomes an or compound inequality. So we're going to write this as two statements. We're going to say x plus 4 is greater than or equal to 6, just like we see it, or x plus 4 is less than or equal to a negative 6. And then we're going to take each of these, solve for x, and plot our solution on the number line. So we subtract 4 from both sides, so x is greater than or equal to 2, or if we subtract 4, x is less than or equal to a negative 10. Now on my number line, I guess it's not big enough. Negative 10 is going to take me further out here. I'll just go ahead and say there's negative 10. So x is less than or equal to negative 10 is going to be a closed circle, and then I'm going to shade all the numbers that are less than negative 10. That shading happens to the left. Or x is greater than or equal to 2, so I'm going to put my closed circle on 2 and shade everything that's greater than that.